All right, so for this round of performance calculations, we're going to focus specifically on the dairy cow example. And the dairy industry uses a little bit different a measure of feeding performance, and it's something that's like a little confusing based on the name, but once you understand what it's doing, it makes total sense. So the dairy industry uses what's called income over feed cost. And you're just taking and comparing the income, and it's really just minus the feed expense. And that's really all it is. It's a pretty straightforward calculation. So in our example, we're working with a dairy person named Jenna, and she has a group of cows that are producing 90 pounds of milk, and that milk is valued at $21.31 per hundredweight. It's premium stuff. And she has a group of dairy cows that are eating about 40 pounds of dry matter. I'm going to put DMI, dry matter intake, per day, and the ration is costing 15 cents per pound of dry matter. So what we need to do is figure out how much is she making with these cows and what her feed expense is. And so to do this, when the feed cost is cost per hundredweight, or the milk price or feed cost, anything's cost or price per hundredweight, all you have to do is simply move the decimal 2 spots and you have price per pound. So if we take the 90 pounds times 0.2131, we get that those cows are producing $19.18 of milk per day. But then we need to figure in what the cow's eating. So if we know she's eating 40 pounds of dry matter, and that dry matter is 15 cents per pound, then she's eating $6 of feed per day. And so we simply subtract, and the difference is $13.18. This is the income over feed cost for Jenna at that period of time. That's all it is. You could do it on a whole dairy basis or an individual cow basis. So depending on, like, if she had 100 cows, you'd multiply this times 100. And so it's just a quick way to assess what is the milk production and the milk value compared to the feed that you're putting in. And so that's how you do an income over feed cost. It's pretty straightforward. You have a few more examples in the homework to work through, but it's simply figuring out the value of the milk being produced and the value of the feed going into the cow. The second thing that we're going to work on is determining our feed cost, or let's see here. Let me rephrase that. And that's driving me nuts. Is when we're pricing feeds. We need to consider the cost per unit of nutrient. Okay, this is a big concept, because when you're turning page on my cheat sheet here, and so when we're figuring out and pricing different sources of feed, we want to be able to make a decision based upon what we're truly after. So, for example, I'm going to do a protein example. So say we're looking at soybean meal and canola meal. If I look up soybean meal in the Noble Feed Library, I find that it's 91% dry matter and 55% crude protein. If I look up canola, it is 90% dry matter and 40% crude protein. And if we have the cost for both of these, say the soybean meal is costing $350 per ton, and the canola is costing $285 per ton. So the question is, which one is cheaper to put in a ration? And so gut instinct may be like, okay, that canola is cheaper. It's $2.85 versus $3.50. But what we really want to base our decision on is, say we're buying a ton of this feed. We know that some of it is water. So we don't want to do that. We want to know how much dry matter we have and how much specifically crude protein are we paying for in this for this feed. So to set these up, I just do it kind of in one equation, so to speak, where we're going to take that cost and divide it by how many pounds of protein. So we know we have 2,000 pounds. And we know it's 91% dry matter. So if we take 2,000 times 0.91, that would tell us the dry matter. But we also know that it's 55% protein inside that dry matter. So if we take the weight of the unit, in this case tons, times the dry matter times the nutrient, then we're going to get that it's $350 for... Oh, I didn't calculate that out. I cut corners in my homework again. 2,000 times 0.91 times 0.55 for 1,001 pounds of crude protein. So divided out, we get that it is 35 cents per pound of crude protein. So if we do the same for the canola meal, which we take the 285 divided by, again, we're working in 2,000 pounds because the units are tons, times 0.90 times 0.40, we get that it's $285. And what you should see is that we know we're going to get less protein out of this because it's 40% versus 55%. But that 2,000 times 0.9 times 0.4 equals 720 pounds of crude protein. So when we divide that one out, what we wind up getting is the 285 divided by 720 is 40 cents per pound of crude protein. So what we find out really is that the soybean meal, even though it costs more per ton, we're going to get more value for our dollar when we put that into a ration looking for protein. We're actually going to wind up having to use less of it, and so it's going to be cheaper per unit of protein than the canola meal. So that's kind of how you can't just look at price per ton. You need to account for the water in the feed, and you need to account for the actual nutrients you're paying for. And so we can do this with calories, just calories per unit, or calories per pound of feed. We can do this with TDN. We can do this with fiber. We can just do this with dry matter, which is what we commonly do for roughages. It's just how much dry matter are they providing. So there's a lot of different ways to do this. And so just remember that you're figuring out that cost per unit, in this case, pound of protein, but it could be megacalories of net energy, but that cost per unit of nutrient of what you're really putting that nutrient or that feed in the diet to cover. So hopefully that helps get you through the next little series in the homework.